Welcome to today's Explainer. We're jumping right into Lesson 7.2 today, focusing on a really fascinating concept, the journey of energy through the natural world. Have you ever actually stopped to think about where your energy comes from? I mean, not just your morning coffee, but the literal biological fuel that keeps your cells firing? Well, that's exactly what we're unpacking right now.
Tigers eat deer. Deer eat grass. Okay, it sounds incredibly simple, right? But how does that energy actually connect them all the way back to the sun? Think about having a simple lunch of chicken and rice. How exactly did the energy required to fuel your body get into that food in the very first place? To figure that out, we have to look at the invisible threads that connect literally every living thing on Earth.
Part 1. The flow of energy. Let's trace exactly where this whole process begins.
We can trace this entire chronological journey starting, as you might guess, right at the sun. Energy reaches the Earth as sunlight. Then a plant, let's say a rice plant, grabs that sunlight and uses it to literally make its own food, storing that energy in its roots, stems, leaves, the whole shebang. Finally, that energy passes into a consumer. Imagine a kid named Arun eating his lunch. When he eats that rice, he is quite literally taking in the solar energy that the plant captured and stored up just for him.
Now here is an absolutely crucial point. The arrows in our ecology diagrams, they don't just mean is eaten by. They specifically show the exact direction the energy is flowing. This is such a common misconception. When you see an arrow pointing from the grass to the deer, you aren't saying the grass is, eating the deer, obviously. You're tracing the path of the energy as it leaves the grass and goes on to fuel the deer's body.
Section 2. Links in the chain. Let's get our scientific vocabulary locked in. The energy journey always starts with a producer. This is the very first organism in a food chain. Plants are our primary producers, and they do this brilliant job of capturing the sun's energy and locking it away. Honestly, without producers, the vast majority of life on Earth would be completely out of luck. They do all the heavy lifting, converting raw sunlight into edible biological fuel for the rest of us.
And because you and I can't photosynthesize, all other organisms in the chain fall into this next category: consumers. I mean, think about it. When was the last time you made a meal just by standing out in the sun? Doesn't work that way, right? Animals, humans included, are always consumers because we literally have to eat plants or other animals to survive. We must consume ready-made food because our bodies just can't generate it from scratch.
So, we can break these consumers down even further based on their diets. Herbivores stick strictly to plants. They're getting their energy directly from the producers. Carnivores, on the flip side, get their energy by eating other animals. Pretty straightforward.
Now, out in the animal kingdom, this dynamic introduces two more really vital terms. You've got the predator, like a cheetah sprinting across the savanna, and its prey, the springbok, desperately trying to not become dinner. The energy transfer here is incredibly high stakes, but fundamentally, it's still just solar energy making a jump from the springbok to the cheetah.
Part 3. Tangled webs of life. Because nature is rarely a simple, straight line.
Like our source material points out, when organisms are connected by their feeding habits, we step up from a simple food chain to a massive, interconnected food web. Multiple linear chains intersect to form these really complex networks.
Zooming out from that single high-speed chase we just talked about, we can see an entire African plains ecosystem connected by these feeding habits. Okay, I know, it looks a little messy at first glance, but if you just follow the arrows, it tells this incredible story of survival and really profound interconnectedness. What's just so fascinating to me about this African food web is how you can trace one single producer, like the grass, branching out to sustain completely different consumers simultaneously, like termites and zebras. The acacia tree and the grass anchor the entire system at the very bottom. From there, the energy just explodes outward. The springbucks, zebras, and termites are herbivores acting as primary consumers. Then, sitting higher up the web, you've got the predators, cheetahs, leopards, hyenas, drawing energy from multiple different prey animals. It's basically this bustling, highly active economy of energy exchange.
Section 4. Models and Reality. Let's put our scientist hats on for a second.
Food chains and webs are scientific models, and they are fantastic tools to help us understand complex dependencies. They have amazing strengths, like clearly showing how plants and animals in the same place rely on each other. But we have to remember their limitations. I mean, it is literally impossible to draw a perfectly complete web of a chaotic, real-world ecosystem. You just can't include every microscopic fungus, every single insect, or every stray blade of grass. But that's okay. Models are there to help us grasp the big picture, even if they have to leave out some of the microscopic details.
So, I'll leave you with this to ponder. Looking at how deeply, deeply intertwined these energy transfers are, how fragile do you think these networks really are if just one link breaks? Like if a disease wipes out the acacia trees, it doesn't just impact the animals eating the leaves. That energy loss ripples all the way up the web to the cheetahs and leopards. It really shows us how absolutely vital every single organism is to the balance of our environment. What would happen to our own food web if a primary producer vanished tomorrow? Thanks for joining me on this explainer, and I'll catch you next time.